Hey kiddos, welcome back to Miss G after 3. I hope that you are going to have a fabulous weekend. However, I also hope that in that weekend you're going to do a little bit of studying for your test that you have next week. To help you with that studying and with the packet that I already gave you guys, I'm going to go over just a couple of reminder examples of how to do systems of equations by both graphing and by substitution. And we'll go over elimination next week, okay? And I'll post a separate video for elimination. So with systems of equations by graphing, first things first, in any systems of equations, you have to remember that your answer is going to be in like coordinate form. You're giving the coordinates because what we're trying to figure out with systems of equations is where our lines intersect, okay? So with graphing, it shows us exactly where they intersect, and our answer is the coordinate of where they're going to intersect, okay? So here we have y equals mx plus b form. Remember, if it's in y equals mx plus b form, how do we graph? The y-intercept and the slope. In the event that you get one that's in, which you don't have that here, but in the event that you get one that's in standard form, ax plus by equals c, remember that we graph using the x-intercepts and the y-intercepts. But let's go ahead and get started with this quick practice problem, which is in y equals mx plus b form, okay? Slope-intercept form. So we look at the first one, which is y equals 4x, okay? We're gonna make this color teal. This line is going to be teal. So we need to ask ourselves first, okay? What is the slope and the y-intercept of this line right here? Our slope is 4, or 4 over 1, because it's rise over run. And since we don't see what our y-intercept here is, since we don't see that b, we know that it's going to be what? That's m is 4 over 1, and b equals 0, which means it's going to start right in the origin, okay? So we're going to come right here at our starting point, which is also our y-intercept, or our b. In this case, for this line, it's 0. So we're going to come right here, and we're going to draw a nice little dot, and then we're going to start with our slope. Notice that our slope is 4 over 1. Is our slope negative or positive? It's positive. Do me a favor and always remember to have your slope arrow, okay? With your slope arrow, it reminds you how the slope is how the lines are supposed to go, all right? We have negative towards the left, positive towards the right. 0 is a horizontal line, vertical line undefined. Since our slope is positive, we know we're going to have to go towards the right, all right? So I'm going to rise 4 from my starting point. 1, 2, 3, 4, and I'm going to run once. 1, 2, 3, 4, and I'm going to run once, okay? And if I want to do it on the bottom, 1, 2, 3, 4, and I'm going to run once. And then I'm going to draw my line. We all know Miss G cannot draw a line to save her life, but we're going to do as best as we can. This is why I tell you guys to make sure that you have a ruler so that you can go through all the points properly so that you can really see where they're intersecting, okay? The next one, I'm going to use purple for my second line, okay? This is my second line, y equals x plus 3. Again, before we do anything, let's figure out our y-intercept and our slope. Our slope, we don't see anything there, which means that it's an invisible one, right? So our slope is 1 over 1. Again, rise, run. And our y-intercept is 3. Again, y-intercept, b, starting point. So since it's positive 3, we're going to start at the origin and count up. 1, 2, 3. We're going to mark it. We're going to look at our slope, 1 over 1, positive. So we're going again to the right. So it's going to go 1 over 1, 1 over 1, 1 over 1. And again, I'm just going to draw my line. And we can see right away where it intersects, which is right here. So now, in order to find our answer, we have to name that coordinate, right? So we know we have to count on the x-axis. And I always tell you guys, as soon as you count it, do it. So we're counting over 1. So it's 1, comma, because our coordinates are always x, comma, y. And we're going to count up 1, 2, 3, 4. 1, comma, 4. So what would my answer be for this system of equations? It is 1, 4. And that's it. That's your answer. And you know, if you want to check it, you could always plug it in, right? This is x, this is y. So if we wanted to plug it in, we would say y equals 4x. 4 equals 4 times 1. Does 4 equal 4? It does, so we got the right answer. Good job, guys. Now we have systems of equations by substitution. We're solving using substitution, okay? Before we did it by graphing so we could see exactly where it intersects. Now we're just solving algebraically to find out where it intersects, all right? So we're gonna have the first line, red. The second one, green. Sorry guys, Miss G's tired. All right, step number 1, first question. Do we have an isolated variable? Yes, we do. We have 2 isolated variables. This is good because it means that we could either plug the 2x here or we could plug the x minus 3 here. Remember, in this case, y is x minus 3, which means x minus 3 is y in the other equation. In this equation, y is 2x, which means x is y in this equation. So it depends on how you want to plug it in, okay? What I'm going to do is I'm just going to plug the top one into the bottom one. So I'm going to say, I'm going to rewrite my problem originally, the one that I'm plugging in. Y equals 2x. What is y? Y is x minus 3. So x minus 3 equals 2x. And now, what do I have? I have a regular equation, right? So now I'm just going to solve. So I'm going to subtract x minus x minus x. That cancels out. I'm left with negative 3 equals x. Bada bing, bada boom, we're done. Now that we know what x is, we have to find what y is. How do we do that? We plug it in. So we can either plug it into the bottom or the top. I personally think that it's easier to plug it into the bottom because it's just a simple multiplication problem. We have y equals 2x. We're plugging it into one of our original equations. And we have y equals 2 times negative 3. What is 2 times negative 3? Negative 6. Which means we have negative 3 comma negative 6 as our answer. Remember that you want to keep your answer in coordinate form. Are we good? We're good. Okay, let's try one that's just a little bit harder, okay? In this one, we have one in y equals mx plus b form, and we have one in standard form, right? Again, let's ask ourselves, is there one that already has an isolated variable? Yes, there is, the top one, which is gonna be purple, and we're gonna make my bottom one teal again, because I'm liking those colors today, okay? So what is y? Y is 2x plus 1. What is 2x plus 1? 2x plus 1 is y. You see how that works? So when we plug it into the bottom equation, we're not going to write y. We're going to write the other name for y, 2x plus 1. Do you understand? So we're going to plug this guy in. Hey. We're going to plug this guy into wherever we see y. So we're going to rewrite our problem. Whatever. 3x plus 4 times 2x plus 1 equals 26. All I just did was I took what y equals and I plugged it into where y was, okay? You're not going to write the y, you're going to write 2x plus 1 because 2x plus 1 is y. From there, we just solved our equation. We get 3x plus, remember you have to distribute, 4 times 2x is 8x. 4 times 1 is 4 equals 26. From here, we have a regular equation, which we should all know how to solve. First step, combine like terms. 3x plus 8x is 11x plus 4 equals 26. I'm going to move this up for you guys a little bit. Now we have 11x plus 4 equals 26, right? What do we need to do now? Subtract the 4 using inverse operations. Cancels out. 11x equals 22. We want to get the x alone, so we're going to divide by 11. So that can cancel. What we do to one side of the equal sign, we do to the other. 22 divided by 11 is 2. Now that we have our x, we're just going to go back to one of the original equations and plug it in, right? I can do it to either one. I'm going to plug it into the first one because the first one looks much easier, right? We have 2x plus 1. I'm sorry. Y equals 2x plus 1. We know that our x is positive 2, right? So over here, I'm going to rewrite it to remind me x equals 2. So I'm going to say y equals 2 times 2 because x equals 2 plus 1. Y equals 4 plus 1. Y equals 5. So I have my coordinates 2, 5. Now, if I wanted to double check to make sure that I got it correct, again, you're just plugging in what you got into your original equations. You can plug it in to whichever ones that you want. I'm going to plug it into the first one because the first one is the easiest and the shortest one to do. Y equals 2x plus 1. So I'm going to put y equals 2x plus 1. Remember that this is x and this is y. So it's going to be 5 equals 2 times 2 plus 1. 5 equals 4 plus 1. Does 5 equal 5? It does, which means we got the correct answer. Okay? Great job, guys. All right, so now you get to try. Here's a practice problem that I want you guys to try. And if you want to know the answer, you can send me a message on Instagram and I will happily tell you the answer so that you can check your work, even though you know how to check your work to make sure you got the right answer anyways. But if you guys want to just double check and make sure with me or just show me that you did it, that would be great. I tell you what, for everybody that shows me that they did it, sends me a screenshot on Instagram or a picture of their work that they actually did it on Instagram, on Monday, I'll give you a ticket, okay? All right, kiddos, here's my little goodbye, kiddos, my last slide, my closing Miss Montana always says that I have to have for you. I hope you have an amazing weekend. Try, practice, and remember, you do that practice problem, you take a picture of it and send it to me on my IG, and you get a ticket on Monday. See ya.